Hello. Hello. Is this audible? Hello.
Yes, it got.
Oh. So welcome back to the one-day international level webinar on adoption of disruptive plan for Industry 4.0, bridging industry academia gap, organized by Department of Computer Science and Engineering, Cooch Behar Government Engineering College, Cooch Behar, West Bengal, in technical collaboration with IEEE Young Professionals, IEEE Kolkata section. Our first session was very much interesting, excellent, and we are also waiting for another interesting session because in this session we have our distinguished speaker, Mr. Prosenjit Banerjee, Director, Banking Enterprise Architecture, Oracle, Singapore. He will deliver on the topic, Future Tech Disruption, Practical Adoption of Digital Technologies. Now I would like to request our HOD sir, Dr. Saurabh De, to introduce the speaker. Dr. De, please.
Very good afternoon, distinguished speaker, participant, and my dear colleagues. It is a glorious moment to extend my warm wishes on behalf of the Department of Computer Science Engineering, Cooch Behar Government Engineering College. In this afternoon session, I want to convey my heartfelt gratitude to Mr. Prosenjit Banerjee, Director, Banking Enterprise Architecture, Oracle, Singapore, for accepting our invitation and giving his consent as an expert speaker in this international webinar. Mr. Prosenjit Banerjee has been a veteran industry practitioner and has been engaged in evangelizing and architecting multiple digital transformation solutions across industries, healthcare, banking and telecom, passionate about big data, cloud, AI, ML, RPA, and other digital technologies. He has been consulting and engaging with multiple top MNCs as well as government or ministries in ASEAN, MEA, and North Asia. Currently, he works as the Director of the Enterprise Architecture for Oracle's Banking and Financial Services Software Division in Singapore. So dear participants, your active participation is important throughout the session. Right now, I am requesting you to mute your speaker microphone to avoid background noises that may distract you from listening the webinar. Throughout the presentation, you can enter your questions after the presentation, and we will also have time for questionnaire session at the end. So I don't wasting the time. Now I hand over the mic to the Mr. Prosenjit Banerjee, and he will deliver a magnificent lecture. Hope he will deliver a magnificent lecture for us. Mr. Banerjee. Sir, your microphone is off.
Sorry about that. Yeah, I'm not a big fan of Google Meet. So thanks, Dr. Saurabh. Thanks, Dr. Shruti Podikari, for the introduction. I'm amazed to get invited by you, reverend people from the academia, and hope the session will be fruitful from a mutual gains perspective. So I'll just try a few logistics. Let me try presenting my screen. Let's see if it is working fine. Dr. Saurabh, please give me a shout out if you can see my screen, see my first slide.
Yeah.
Okay.
This is.
So I am audible. My slides are on screen. Just give me a cue when I can start. Means if you want to wait a couple of minutes for other people to join in, that's fine.
Audible and visible also.
So, friends, very good afternoon. Very good afternoon on a Saturday my evening, your afternoon. Few things I wanted to set up as a logistics before I start my presentation. I am not a big lecturer, so I would like you really want to interact with me, stop me and interrupt me whenever you want to through the chat. So I would like questions. If I don't get questions, that is the essentially industry thing. If I don't get questions, I kind of feel that probably I'm either making too much sense or I'm not making sense at all. So please feel free to put in questions in the chat. And I don't know whether I can see the chat as well as the slide together, but every shout out, I will take a 10 to 20-second break after every slide, and I will try to see if there are questions for me. So that is one. One more thing I wanted to tell you before I start. So this webinar actually takes me back kind of 20 years from now. So there was a time when myself, your revered head of department of CSC, Dr. Saurabh, and the distinguished speaker whom you enjoyed this morning session, Dr. Rick, we were actually friends in the same college. So today's webinar actually brings me back to my college days, where Dr. Saurabh, Dr. Rick, and myself were actually learning the basics of computer science. We never thought that the industry or the world outside, how it is going to act for us in the next decades to pass on. However, it has acted good for all of us. We are all there, and thanks again, a big thanks again for Dr. Saurabh and Dr. Reed to engage with me on this webinar. So let's get down to business. So today I'm going to present probably not much of theory, but more of experience, and experience around how IT and more so how this future techs enable us, the software companies, as well as enable the clients to make money. So we are in the business of making money, right? So every new idea, every new research, every new experiment should be industrialized. So industrialization is the key. So today I will focus my next 1 hour more on how we have seen good examples of getting theories industrialized, and at the same time how we have seen great theories not getting industrialized as much. As we come to our term Industry 4.0, so Industry 4.0 is a term, a smart, connected, insight-driven industry. So we will focus more on what are the key things that are needed apart from the good theories and research to make it into an industrialized solution. With that, I will go to my first slide, and as I said, I'll like this interactive. The first slide is basically the key takeaway out of this next 1 hour. So basically, it's you can see it like a Netflix movie list or an Amazon Prime movie list, whichever you are subscribed to. So there are three movie posters on the screen. Now, my friends, my colleagues, my peers, these three are the benchmark movies according to me when it comes to future tech, disruption, and industrialization of the same. Now use your chat. I would suggest you use your chat, and let's see who gets all the three correct names of these movies. We'll take a break. We will go back to chat. Use your chat. I'll also open my chat. It is here. So please feel free, use your chat and tell me what are these three movies. Let's start with an icebreaker. Wonderful. Devoshmita, the second one is her. And in fact, out of these three, her is my favorite. Her talks about a AI powered personal family member. So basically, operating system which became somebody's family, which was powered by AI and soft robots. How about 1 and 3? 1 should be the easiest, right? Five more seconds, guys. Anybody on 1 and 3? One is Mission Impossible. Yeah. Thanks, Sumana. By the way, Sumana is my wife, so I have requested her to join this webinar as well. So she is my wife. So thanks, Sumana. One is Mission Impossible. How about number 3? I'm showing the slide again. How about number 3? Okay. If there is no answer, I'll give you the answer for number 3. The number 3. Yeah, go ahead, Prashanjit.
The third one is Ex Machina, released in 2016.
Wonderful, Prashanjit. So it's Minority Report, her, and Ex Machina, and we can debate, but her is the best movie. Yeah. So great, guys. So these three, as I said, were the examples wherein theories and researches and path-breaking future technologies has been aptly industrialized. So let me go forward. So in the industrialization world of IT, I have been fortunate enough to go through 4 eras. So the IT industry every 5 to 7 years has a era which is driven by a buzzword. So when I joined IT back in 2002, 2003, the biggest buzzword was business intelligence. If you see today's IT industry, the industry 4.0, where is business intelligence? It is still there, but the value derived from business intelligence has gone down. Then we came into an era which used to be a very small era, which used to be called as SMAC. So it was a concatenation of social, mobile, analytics, and cloud. And that is the era which actually is driving the digital buzzword which is there in the market, along with big data. So basically, IT will find its new buzzwords. And each of these buzzwords are driven by research, driven by theories, and has been successfully industrialized so that they can solve real business problems out there with our clients. I have worked mostly in the telecom industry, healthcare industry, and now in banking industry. So I will keep my discussion focus on these 3 industries primarily during the next 1 hour. But if you see these 3 industries, let's say the telecom, the healthcare, the banking, the retail industry, the insurance industry, some of them are early adopters of these technologies, more so like banking and telecom. So any new thing in the market, you will see banking clients and telecom clients adopt that. Some of them are followers. People like insurance, healthcare, industries like insurance, healthcare, they are more of followers. So this gives us a great mesh. While there are certain industries who test out researches and theories fast, there are certain industries who wait for the theories and researches to mature to a cycle before they can industrialize and internalize that. So with that, so the key takeaway from this slide is the IT industry creates buzzwords to sustain. And when we are in that era of that industry, it is upon us how to use these researches, how to use these theories and experiments to create business solutions. And we will be talking about the business solutions in the coming slides. But before that, let me touch upon the definition of digital. Everybody is talking digital nowadays. You can hear words like everybody is AI powered, Everybody claims to be on top of 5G. You will hear buzzwords like bitcoins, blockchains, artificial intelligence, machine learning, of course, robotic processes, soft robots as well as hard robots. You will hear buzzwords called cybernetics. So what exactly drives the uptake of digital? So there is a nice illustration by Gartner, which you will, let me see if I can change to laser. So at the left, I have included a hype cycle of emerging technologies. It's a research from Gartner, which you will see talks more about the industrialization of all these buzzwords. Things like connected vehicles, things like using composite AI in the healthcare field, things like augmented development of AI, things like embedded AI data fabric. We will talk about more of them later. Things like health passports. All these things are industrialized examples of the buzzwords that you see on the right. So the three key things, again, that is driving the digital transformation. One, the buzzwords or the researchers behind it. Number two, the industrialization of those buzzwords. And number three, last but not least, is the adoption of those buzzwords. So if you see, there is one more chart in my slide on the right bottom of it, showing which of the countries are adopting digital more than the others. Of course, the leaders who are standing out are US, UK, Japan, Singapore, New Zealand, Germany, a bit of Canada, Australia as well. And India is very much in the mix. India, Brazil, China is very much in the mix. However, this digital buzzword has become ubiquitous. When I say ubiquitous, I'll give you an example. So if I look around my calendar for my previous week, so I had 3 customer presentations. Imagine where those customer presentations were, and they were all about digitizing their entire IT landscape. Imagine where those customers were from. I'll tell you. One was from Somalia, one was from Uzbekistan, and one was from Jordan. Now, can you really picture a client in Somalia going for a digital transformation of their IT landscape using AI, ML, robotic processes, 5G, blockchain, etc., to increase their business value? So that is the power of digital. Digital technologies is no more only in the hands of the rich and only in the hands of US, UK, and the so-called developed countries. In fact, the third world and the emerging countries are the biggest countries where the uptake of digital is seeing actually a speed which is unprecedented. So with these three key takeaways on buzzwords, industrialization, and a universal adoption that is driving the digital hype cycles, I will get to my next slide. I'll take a pause here. Feel free to ask any question till now. I will probably not be able to see the chat. So if somebody can read out the chat questions for me, that also helps. If there is a question on a chat. Let me see the chat. If not, we will go ahead.
There is no question in the chat box till now.
Yeah. So let's go ahead. So little bit about this industrialization that I was talking. So 4 things have actually enabled this technology industrialization for digital. And those 4 things are: number 1, infrastructure at scale. When I say infrastructure at scale, I'm talking about the clouds. I'm talking about the serverless technologies, which has actually brought down the cost of infrastructure on a scale from 100 to maybe 10. So earlier, if the capital expenditure on infrastructure was $100, it has now come down to $10. thanks to cloud, serverless, software as a service, and similar technologies. And using this infrastructure of scale, things like we have been able to deliver things like connected devices and embedded intelligence. Embedded intelligence is our good old data mining, AI, ML, etc., but used in real time. So nobody cares in the industry. Nobody cares about a great data mining model churning out results, but those results are not integrated back into your workflow in the real time. I'll give you an example. So let's say I want to apply for a loan in a bank. I'm a retail user. I'm a office goer, 9 to 5 office goer, and I need a 2 lakhs personal loan. Now I don't have an account with the bank. So
sorry for the interruption.
Sure.
Are you sharing any screen?
Am I not? Did the share go up? Oh, okay.
Now it is.
I'm back.
Yes.
Yeah. So we were talking about infrastructure at scale, which is basically the cloud computing, software as a service, serverless kind of technologies, which has brought down your cost of infrastructure. Now, with your cost of infrastructure getting down, companies are able to, the industry is able to test out their ideas, the business ideas, etc., like embedded intelligence, connected devices, IIoT. IIoT means industrial IoTs. So basically, IoTs applied to machines, planes, vehicles, cars, etc. So they are able to test out their strategies, test out their ideas very easily at a very low cost using this infrastructure at scale. So one example, so I was talking about office goer who needs a loan of 2 lakhs but doesn't have an account in any bank. So earlier days, you would have to. Sorry, is there a disturbance or a question? If you would mute yourself, please. Yeah. So earlier days, he would need to go to a bank. He would need to stand in a line. He would need to fill up forms. He would need to put his picture. He would need to give his supporting documents, and maybe after 3-4 days, the account will be opened. The loan will be given. The loan will be either given or rejected. So see the time taken to give services to a customer, and time taken as well also the effort that is being put in by the bank staff to get this loan and the account opening out. Now what you do, using the digital technologies, you just go to your mobile, download the HDFC or ICICI or whatever bank app. In that bank's app, if the bank has actually adopted digital, in the bank's app, you take a selfie. You fill a digital form, you attach your passport copy, and you submit. That is what you do. 5 minutes is what it takes for you to apply a loan or apply for an account opening. Now let's see what is happening at the bank side. So how digital or how this embedded intelligence and connected devices are helping in this entire loan and account opening workflow. So at the back end of the bank, there are soft robots, or RPAs as we call them, who are doing multiple things on behalf of the physical human staff in the bank. So number one, what he is doing, he is taking the picture from the passport that you have uploaded and checking it against your selfie that you have submitted. It is also going to some other database. It might also go to some other database and automatically test if the picture that you have submitted matches with the other picture, and might be some certain other databases which are there in the country. So all of these things is done within seconds by a soft robot which has been deployed back in the bank in some computer on cloud. Then what it is doing is that it is creating the entire the checks, passbooks, and all those things. it is creating the check numbers, it is creating your account numbers, it is creating a user in the database, and it is putting you a mail that your account is open. It is also going back and based on AI ML, it is seeing that whether you are credit worthy or not, whether you should be given a loan or not, give a loan of 2 lakhs or not, given your credit rating or your monthly salary and all these things. So the entire enrichment, the entire validation of your documents, and the entire decision making for the loans and account opening is happening within seconds. So what did we gain here? What is the business value we gain here? We could cut down the time to get you a loan from 4 days to maybe 4 minutes, and that translates in dollars, guys, hard dollars. Two ways. One is your costs are down. You can save a lot on in people's efforts, and second, you have a customer now who is delighted at the experience. That is where I go to this part called new channels, who are delighted at this experience and who is likely to stick with you for many more years than a traditional customer who is going to a bank and ever complaining that why my loan application is taking 4 days, 2 weeks to get processed. So we have hard dollar saved, we have a happy customer. Then I will go to my next point, which is the new channels. So now you have hard dollar saved, you have a new customer at a very less time and who is a happy customer. Now this customer is a new gen customer who is not only satisfied with an internet portal. So the digital technologies is also bringing new channels like chatbots, like wearables, things like you can actually open up a chatbot nowadays and put in a message there. How much is my account balance? The chatbot, which is again backed by a soft robot, is going to go back to the bank's database and give you your current account balance. No need to go to a bank to update your your passbook like the older days. Things about API economy. How these digital technologies are bringing in a very sustainable economy. Let me give you an example. So till now I was in banks. Now let me go further from banks. So let's say somebody has to do. I'm moving a bit into healthcare. Somebody has to do a cancer related surgery, a neck cancer related surgery, or a spine cancer related surgery, very complex surgery. Let's say he comes from a city or a town where there are no big hospitals or good doctors who can do that surgery. So what he will do, he will actually go to the nearest big city or town. So maybe he will go to some place like Calcutta or Delhi and book appointment with a doctor to get the surgery in a specified day. Now, where comes the economy? So that's pretty straightforward, right? We were doing that in the pre-digital era as well. What are we are doing new here? So many a times when you go to the new city for such kind of a healthcare treatment, which might be a prolonged treatment, it might involve a surgery, it might involve 5-6 radiations over 3 months. You might not be able to go back and forth to your city. Maybe that will cost more than living in the city for 5-6 months or 2-3 months, whatever that timeline is. Nowadays, the digital economy is allowing a marketplace to be created, wherein, think about a restaurant menu, wherein you have starters. The starters is the surgery that you are going to do. You can book the starters on the web, the surgeries that you want to do, the doctors you want to have doing your surgery, but also you can book in the same marketplace at a lower cost. You can rent a place near to the hospital. Then you can also book somebody who is going to give you a physiotherapy service twice in a week once you are done with the surgery, to help in your help you rejuvenate. You can also book in the same marketplace. Let's say the total package, surgery package costs 15 lakhs. You don't have that much money. You can also book in the same marketplace a loan from one of the leading banks who will fund your surgery. So if you see, what we are talking about is a healthcare marketplace, wherein not only the healthcare services, but retail service, real estate services, retail services, as well as banking services are published together, and a consumer can choose, can see which ones work best for him, and create a product bundle, create a bundle which caters to not only the healthcare needs, but also takes care of his rental needs for those months, uh, takes care of his retail needs of physiotherapy and medicine and all those things, and takes care of funding that entire procedure backed by a bank loan. So that is what we are talking about in marketplace and API economy. How is all of this happening? So all the industries, all the people who are adopting digital, they are exposing their services and prices through something called API. APIs are means through which two different organizations can exchange their products, services, offerings, ideas, or can post all of them in a common marketplace. We are seeing a lot of uptake of that. India is still catching up. I would say this marketplace and economy is more prevalent in the matured cultures, but that is the future we are going at, wherein there would be barrierless organizations. There would be no more banks only, hospitals only, real estate agents only, pharma and medicines only standalone. They will all collaborate to give you a marketplace kind of economy using the digital disruptive technologies. So interesting, very interesting. So probably, I guess I have been able to give you a feeler about how Industry 4.0 is making money using the same AI/ML, cloud, IoT, sensor data, computer vision, and stuff that the academia is doing research upon. So this is the way, guys. The gap between the industry and the academia is becoming narrower and narrower. So we are using industrialization of lot of researches. The most popular ones right now is computer vision, soft robots, and real robots. So a quick one on the soft and real robots here is quick examples. Things like, so you write a mail to your bank that I want to do these transactions on these days. Do you really think anybody in the bank reads it? The answer is mostly no for any of the banks who has gone into digital technologies. So they are using number one, NLP, to read the contents from your mail and understand the intent of why you have written that mail. And then based on the intent, the soft robots are going to do the transaction at the back end and give you back the result. So that is an example, very good example of the soft robots. Real robots, we are using a lot of real robots and Aka terminators kind of in the healthcare as well as the manufacturing space. Nowadays, let's say a very complex surgery, maybe there is only 5 physicians in the world, 5 surgeons in the world who can do that surgery, and they are not in India. You can actually use real robotic arms to do invasive surgeries, wherein the robotic arm is being controlled by the surgeon sitting in some other country. This is not science fiction. And in fact, I can't take names on this webinar. In fact, at least I have worked with 3 hospitals in India which have this technology, which are adopting or already has these technologies. In certain of their complex surgeries, they have already gone down that path. One more very interesting topic is digital twins. We will talk about it in one of the slides, one of the upcoming slides, but just to give you a feeler, this is one of the big hot things which is probably going to take the industry from 4.0 to 5.0 as we will. So digital twins is actually making a complete replica of an object digitally. It might be on a hologram, it might be using AR VR technologies. Things like, think about the possibilities when digital twins can become mainstream. So students in medical colleges will no more need dead bodies to practice their surgeries. They can practice surgeries on a perfectly built digital twin of a human. Now, digital twin is not only, compartmentalized only for human beings or only for living objects. Manufacturing as well as certain other industries are using, for example, like ports, shipping and seaports. They are using digital twins to completely build a holographic model of their entire operations, manufacturing factories, workshops, shop floors, wherein they can simulate multiple tests, or they can test out. Is there a question? Guess not. So they can simulate multiple tests. So tests for resilience, tests for performance. So before launching a car or a product to the market, they can very well use digital twins to buy out their ideas. How are their ideas helping? So creating near real life situations, but on a holographic or a digital twin mode. Something which is not yet very much mainstream, but something which is going to redefine our future very soon, probably in the next 3 to 4 years. Going ahead, so as I said, industrialization is the key. So let us look at it, what we mean by this industrialization of digital architecture. I call this slide my rainbow slide. And for my engineer friends out there, for my computer science engineer friends out there, probably this slide is going to be a bit interesting for you, because till now I was talking on air. Basically, I was talking about dreams, I was talking about ideas, nothing was concrete. So let's see how we are making it concrete, how the industry is making it concrete, how the architecture is changing. So in the pre-digital era, let me draw up an architecture of the pre-digital era and compare it with the architecture of the digital era. In the pre-digital era, every company, as you can understand, would control a data center where they will have physical machines. They will virtualize the machines, put a managed services layer, which is the administrators and the engineers in the data center, and manage the entire infrastructure. So essentially, while I am going for IT, the first thing I needed was a big house or a big space, big floor space, where I will put the racks, the cables, the networks, the routers, the connectivity, the firewalls, everything, and of course the servers and the blades and the mountings of them. Then on top of that, in the pre-digital era, we used to build data stores. All the database technologies that you are familiar with, the RDBMS, the data warehouses, OLAP, etc. And we used to build our applications on Javas and .NETs and C# and whatnot on top of the data store. So basically, that was the entire architecture of the pre-digital era. We of course had channels and user experience. So while we are doing all these applications, we have to get the application back to the customers or the users. How we used to do that? We had mobiles, we had portals. We used SMS and other channels. That was pretty much the pre-digital era entire architecture. And analytics and data mining was somewhere hovering around. It was somewhere between the application layer and the database layer. It was somewhere hovering around, was just getting mainstream. So that was my pre-digital computer architecture. How it has changed. Now comes my rainbow slide. So first, the infrastructure has been completely transformed. So in today's world, nobody goes and buys a data center and puts a $1 million worth of hardwares and services, networks, routers to create his IT landscape. People are moving absolutely towards cloud. People are moving towards serverless technologies. People are moving to edge computing. People will be moving to quantum computing. Let me not get into details of the digital platforms here, because that's what I intend to do in my next slide. But let me just go forward and talk to you about the other tiers of the digital technology. So digital platforms is giving us the base on which the digital technologies can innovate. The databases. So earlier it was only the relational databases and data warehouses. Now you have streaming data, sensor data, NoSQL data like web pages putting JSON data format, social media is putting their Twitter and Facebook feeds, as well as geospatial data that is directly coming from location-based services. So all this data needs to be connected to the erstwhile relational customer account billing kind of data to make it a real digital solution. Then in the application tier, the transformation has been the biggest and spell breaking. So there has been automation technologies that has been brought in, things like RPA, digital assistance, things like orchestration and choreography, things like event-based automation. Event-based automation is a mail comes in and for certain robots gets activated based on that mail. Things like simulation modeling and operational research. I talked about the digital twins where you can simulate real life experiences on a holographic image and things like that. And computer vision. We are more and more using image, video, as well as computer vision technologies to do crowd management, to do customer behavior and customer mood management, to do things like fraud and risk detection and things like that. All of these automation technologies are absolutely backed by real-time embedded intelligence. Talk about AI, machine learning, all the good models academia is building for us. You talk about cognitive computing, you talk about natural language processing, you talk about OCRs, which is optically reading the contents of a document. All of this are backing this automation, and this automation is being delivered not as a big fat program as it was in the pre-digital era. It is being delivered as things like APIs, modular components, and microservices. I will not get into deep detail of that. I am sure you will find your way through it once you are deploying industry level digital systems. However, I will go to the next level of, so I have my data, I have my cloud on which I have gotten my sensor, customer, every data and connected it, and I have built an application. Now, how I am going to give it back to the users? Nobody is only satisfied with a portal or a mobile nowadays. So I am giving back my experiences to chatbots through voice-based systems like Siri and Alexa. I can really do a Siri or Alexa-based banking or movie ticket booking or even buying my groceries today. So all of this is happening because of this automation and AI layer built into my application, and the data layer connecting my customer data, my accounts data, my billing and product data with my sensor data, my social data, my location-based geospatial data, everything. So connected data, cloud, connected data, modern automated applications being delivered on omni-channel, as we call it. That's another buzzword. On omni-channels like voice, variables, AR, VR, 3D printing and digital twins have kept together, because I like to call them as alternate technologies, as well as robotics and humanoids. So robotics, automated vehicles and humanoids. So we are pushing our application no more into an internet portal only or a mobile app only. We are pushing applications in all these omni-channel experiences that are consumable by a user at any point anytime at any place of his choice. So the final part of this entire digital architecture is ecosystem. As I was talking about a marketplace. So basically all these experiences can be consumed by marketplaces or can be consumed between organizations. So things like a Citibank mobile app might let you see the account balances of let's say your HDFC account in case Citibank and HDFC has an agreement to share data between them. So many banks, many healthcare, many hospitals, many retails, many manufacturing are using this digital collaboration and digital ecosystems to monetize their data. So basically, let's say one of the organizations have your account details, the other organization sells insurance, and based on your spend parameters, they have understood that you run a family of 4, and hence they can give you a personalized insurance for your entire family, wherein you are allowed to go to certain hospitals as health insurance, and you are allowed to keep a part of it as life insurance. So all these complex products, so you see there is a bank who is collaborating with an insurance agent who is in turn collaborating with a hospital. So all these database collaborations, these marketplaces, these data monetizations as we call it, are actually what is driving the industry 4.0 beyond to industry 5.0 and probably later. So it's an economy wherein we are using technology, automation, cloud, AI, ML, connected data to create more money for every organization, be it in any industry. So that's what the digital economy is. I'll take a pause here. Any questions till now? And if there is something on chat, one of you will need to please read it out for me.
Dear participants, do you have any questions?
So guys, as I told earlier, either I am making too much sense or I am making no sense at all. So any feedback, anything you want me to delve deep or discuss more, please feel free to put in questions. I get very kind of jittery when I am not getting questions from the other side.
Okay, Rahul Amin send a question. Is it legal to share such our data to others?
Very good question. So there is one more tier in this diagram which I have not put in because I didn't have so much space in my slide. So that box reads regulatory and compliance. So without regulation and compliance, the answer is no. However, with regulation and compliance, and you will not know that whenever you are signing up for any of the forms or whenever you are going to give your data to any of these organizations, there is some small checkbox somewhere wherein you are giving your consent to use your data for industrial purposes. So if you don't believe me, next time you go for signing up for something, just check out for those small terms and conditions. It will have it somewhere. There are regulations, there are compliances, there are things that can be shared with anonymization. So not all data can be shared like that. So that's why I said regulatory is a different tier in this architecture as well. Data needs to go through anonymization, wherein your name and your personally identifiable details will be masked, and then the data can be shared for industrial business value making. Then there are other things, other models of data handling, things like blockchain or things like hyperledger, wherein two organizations can share your data but not your details. So only the details that you have made so many transactions in the last few months, that can be shared, but the details of the transaction cannot be shared. Then what the other party does is that the two parties keep track of your primary key, if I will. So keep track you as a primary key through certain tokens or through certain anonymized capture IDs and things like that, wherein a part of your data belongs to the organization A. Let's say it's a part of your data belongs to the hospital. Let's say where the bank and an insurance company and a hospital is collaborating, and a part of your data belongs to the insurance. And by regulatory compliance, it is ensured that only that part which is relevant to that organization lives in the premises of that organization. I hope I made it clear, Rahul.
Dr. Chandra said explain about cloud computing.
Wonderful, sir. If you can bear with me for one more slide, I think my next slide is about cloud.
Deepayan Das requested you to, sir, please can the slides be shared to all participants? That would be very helpful.
Absolutely, yes. Absolutely, yes. We will do that after the webinar is over. So, as I say, my next slide was about cloud platforms and infrastructure. And I will, rather than going technical, I will go with a story, analogy with real estate. So, it's in the pre-digital era. So, let's say you are in the real estate business. What did you used to do? You buy a building first. Then you buy a building, or you actually put up a high rise with 15, 20, whatever stories. Now you sell out flats till all the flats are full. So you keep on selling flats, and the buyer is paying for the flat as well as the money apportioned for the super built up facilities like the swimming pool, the garden, the lift lobby area, etc. are all super built up facilities, right? We all know. So the buyer is not only paying for the flat but also an apportioned money for the entire facilities that you have invested upon. So essentially you are shifting your cost to your buyer on day one. So basically, whenever you are taking the money from the bank out, you are shifting your cost onto your buyer. That was the pre-digital data center kind of an infrastructure, wherein the first day I am starting my company, I need my IT. I will somebody will come and sell me a data center with power, cooling, AC, and all the security guards outside, where I will buy huge racks of servers, networks, monitors. I will have to pay for them on day one and set up everything even before I have had the first customer on board. So let's say I am a retail chain. I have planned to open 10 shops. All the 10 shops is going to have my point of sales and billing application. Even before the first customer has entered my premises, I have invested hundreds of millions in building a data center, servers, networks, switches, routers, everything, even before I have got my first dollar. That's my investment. That's before cloud. Now, what is cloud? Cloud is a virtual building, multiple virtual buildings, or in this analogy format. Now, as a real estate agent, what I am telling my buyer is, I have many buildings, many towers, adjoint towers. You need a flat? I'll give you a flat. What kind of a flat you need? You need a duplex, or you need a 1 bedroom, or you need a 3 BHK fully furnished? I will give you a flat, but I cannot guarantee you in which tower your flat is going to be. Or think like a hotel. A hotel has multiple towers. You check into a hotel, you ask for a presidential suite, or you ask for a two bedroom room, 2 bed room. The hotel gives you that, but the hotel will not be able to guarantee you in which tower you will get your room. So essentially, whichever tower is available, or whichever flat is available and is closest to your requirement, they will give you that room or that flat. This is essentially what cloud is. People like AWS, Amazon, Oracle, IBM, Azure is Microsoft. What they have done is that they have taken data centers in multiple parts of the world. Okay, and in their data centers, they have built hundreds of those big servers. Means 200 CPU, 300 CPU compute capacity, multiple servers in a server farm. They have put in the network, storage, SAN, NAS, routers, firewalls. They have invested in anything. As a client, as a bank or a hospital, I will go to Oracle or Amazon or Azure. I will ask that I need 24 compute cores and 4 terabytes of data for the next 5 months. That is what cloud is. That is what I'm paying for. I do not need to know that how you are managing the security of the cloud. I do not need to know that how you are making money, how you are doing upgrades, patches. That's your problem. I am going to take a rental of the exact capacity that I need. Now think of that retail chain who was opening the retail shops, who had to put hundreds of millions of dollars before the first customer even came in. Now what happens? The same retail shop goes to Amazon, Oracle, or Azure, tells that I am going to avail your cloud. In the next 4 months, I will open only one shop. So I need only 4 compute units. I only buy 4 compute units from you. Next 8 months, I will open 10 more shops. So I will need 20 more compute units. I will buy only 20 more compute units for that time. Now, in any of the months, I close any of my shops, I will give back the compute units I have rented from you. So essentially, it's like a hotel or a night stay or a kind of a thing. So that's what infrastructure as a service is. So when the cloud companies are bundling softwares on top of infrastructure, it becomes software as a service. So cloud runs on multiple models. You can only buy infrastructure based on your needs from a cloud provider. You can buy infrastructure plus databases like Oracle database, SQL Server database deployed on that infrastructure, or you can buy entire software products like a SAP ERP with the database, with the infrastructure beneath. So multiple models. And again, I will go back to that marketplace kind of an economy. So all the software sellers are now publishing their software products on cloud marketplaces. So Amazon, Oracle, Azure, each has their own marketplace. So let's say SAP, Oracle, each has their own ERPs. If you go to a Amazon or Oracle or Azure marketplace, you will see SAP ERP, PeopleSoft CRM, multiple other applications available there to be consumed as a restaurant menu on top of the cloud compute powers that you have bought. So we are going from infrastructure as a service to platform as a service to entire software as a service. So the rates will go by hour. Means you might buy SAP ERP by 1 day for 1 day, and the next day you just give up the licenses. Possible. So unit flexibility, the agility, unit flexibility, and pay as you go. These are the 3 things which define cloud. And even cloud is not enough. We are going to an era which is called serverless. So till now, cloud was giving you kind of a benefit where you need not put a lot of money to buy all these things. Rather than you can pay as you go, you can scale up, scale down your compute powers as you need and stuff like that. But what if I told you there will be no servers in the world? That's again science fiction, right? Not really. Means there will be servers, but servers or compute powers or infrastructure will no more be a unit of buying. So we are changing the unit of buying here. Let's see how it is. So serverless is like you have gone to a hotel Hotel will ask you to check in for 1 night or 2 nights. You don't want to do that. You don't want to use in a hotel room there are multiple facilities, right? There is a mini bar, there is a TV, there is a fridge, there is a bed. You don't want to use all of that. You say that I will sleep on the bed only for 2 hours and drink or maybe watch TV for 20 minutes. So I am only going to pay you for the 2 hours of bed and 20 minutes of the TV. That's what serverless is. So basically, serverless is giving you a compute power for the time you need and taking it back to the pool of compute power that I am maintaining and giving it to the next person the moment he needs it. So let's say I, Prasenjit Banerjee, go to Amazon and take a compute, or so let's say I want to access let's say I want to book a movie ticket. The moment I am trying to do a transaction for movie ticket, a very small computer is actually dedicated to me, which downloads the movie ticket application onto it. And the moment I have booked my movie ticket and the money has reached not mine, but the money has reached to the movie hall owners, the computer is gone. My transaction is over. The computer goes back to the pool. So some other person comes in. He wants to buy groceries from Red Mart. Again, a microcomputer, maybe using the same CPU core, is created, which downloads the. Actually, it's not downloading. They have kind of something called image management and Dockerization, containerization, etc. I'm not going into those complications. So basically, it will deploy the Red Mart application on the same compute which I was using 1 minute earlier. It will deploy it will delete the movie ticket booking application from my compute and deploy the Red Mart on that same compute core and give the other person the capability to order fruits and vegetables from Red Mart. Once he has finished with the transaction and the Red Mart guys has got the order and the money, again the compute core goes back to the pool and becomes ready for the next person to come in for whatever application he wants to run on it. So essentially, there is no concept of dedicated server to banks and things like that. So that's why it's called serverless. So we are going into a world where the provisioning of every application is automated. There is no administration needed. You only pay for the service, the transaction you are doing, not for the software and the hardware. And innovation is ubiquitous, which means that using this model, a Red Mart or a Red Mart can actually innovate the mobile app every day without really going into the end-to-end software development life cycle of testing, pre-deployment, and all those things. You can pretty much do things faster, innovate faster, and push out your innovations to your clients much faster. So one more example here before I go to my last set of slides on serverless. So I will take an example of Amazon Alexa. Alexa were probably the pioneers in serverless technology. So basically what happens, have you ever thought what happens beyond an Alexa? How does Alexa work? Or for that example, a Siri or a Google Voice work? So the thing that is called AWS Lambda that you see here, the name will be different for different companies. So Siri will have a different name, Google will have its different name, but essentially this is a serverless function which creates its own microcomputer, the small CPU core, and deploys your application on top of it, lets you do the transaction and self-destroys and goes back to the pool. So this is the serverless function. It might have different names. Oracle called it OCI functions, Azure calls it Azure functions, Amazon calls it Lambda, etc. So imagine that you are giving a command to Alexa. So Alexa, what is my account balance? So something.
Sorry, I don't know that one.
Oh, sorry, my Alexa woke up when I was talking to you. So what it will do is that it will create a
I'm not quite sure how to help you with that.
it is going to create a very small computer out here, deploy the application and send it back to the back-end processors. So there is something called Amazon Poly. Amazon Poly is the guy who takes handover from your voice-based command, which you have given to Alexa to Lambda, and it changes the voice to text and then pushes it to natural language processing. All those applications are being serverless. So all these microservers are being built. The time you spoke, you gave the command to Alexa or Siri, and it goes to a data store behind where there are question answer key value pairs. So the answer will again come back to you through Amazon Poly. Poly will ensure that it changes the text to a voice and gives back to Lambda, and Lambda gives it back to Alexa. So this is nice. But remember, Alexa is serverless, but it is not persistent. As in, Alexa and Siri today can't remember what is your birthday, which food you like, and things like that. But while we are going to industrialize this kind of a solution in any industry, bank, hospital, insurance, we need persistence because we have to identify our customers. If a customer wants to do a transaction, I cannot identify a customer. My transaction will not go through. So how to use this? So there what we do is that what we build up is that, again, I'm joining now Alexa with the APIs and the digital technologies I was talking earlier. We join our digital data hubs, put APIs on top of that, and put the processing logic guarded by security. This secure all of this database and the security are persistent. You have your user ID, passwords, OTPs, multi-factor authentications, your face recognition, your thumb recognition, everything is managed by the security module and the persistent data store. And we bring the processing logic back to Lambda as a serverless function. So my processing logic becomes serverless. My data behind my account, billing, customer order, product data becomes persistent, and I am running on a serverless engine to ask Alexa to book my tickets, what is my account balance, what is the cheapest Mumbai-Delhi airfare for tomorrow. Essentially, all this are going back to the serverless functions that I have built. No more about Alexa. Siri and Google will get angry with me. So let's go ahead. Any questions on serverless till now? I have just a couple of more slides to end, but before that. If not, let me go through. So I just wanted to plot all the future technologies on a mainstream application, mainstream adoption curve. So as you can see, for my engineer and student friends out there, as you can see, this is one of the things when you are going to come out of your engineering college and probably go for the industry. These are some things you will have to keep in mind. How to shape your future. So there are multiple such adoption curves. Some of the curves have a have a very high digital skill pool. What I mean is that there are thousands of engineers out there in the market for some of these technologies. Some of these technologies are technologies where we, as an industry practitioners, we fight to get real good skills. Of course, you know, which are more rare is the skill, the more better career you will probably have. The more rare is your skill. And then there are certain skills which are more highly paid than certain other skills because it brings more value to business. So with this chart as a combination, you will probably want to plan your future. So if some of you wants to get into kind of computer vision technologies, you will know where you can actually potentially see yourself in 5-10 years from now. So which of these adoption pointers you are going to focus your post-engineering life upon. And remember, this chart is very fluid. It probably changes every 6 months. So you need to keep a look at the industry trends and keep a real good hand on which all technologies are coming, going, which all technologies are getting dead, which all technologies people have built a huge workforce and it's a crowded market out there and things like that. So my last set of slides is on transformative projects. So three things industry sees so that they can fund the digital transformation that is coming out of research and all the good future tech technologies. One is on the left hand side is business value. So this is a business value curve. So any new transformative technology you bring in, there has to be a quick win and there has to be a long-term value. Then it has to change the experience of your users. So cycles of innovations. So multiple innovations, multiple new experiences to users. You might want to start off your user experience with mobile apps, go to chatbots, go to virtual assistants, go to voice-based transactions from there. So digital technology should be elevating experience. It should be creating business value for the company. It should be elevating experience for the end users. And the last but not the least, it should be sustainable. So obviously there is a big money, this IT expenses, which a company has to put in on day one. And as I said, even with cloud, to develop the applications on cloud, there is some money that needs to be put. And the customer uptake will start from zero customer on day one. So there needs to be an essential scale of customers, after which the IT expenses of the digital transformation will start making sense. Basically making profits. It will start making profits. So this model should be scalable. So this graph or this gap between the business growth and the continuing expenses needs to be wider and wider. The more wider it is, more profit for the company and more sustainable the transformation is. Giving you an example. So my revered friend Rick, he was talking about image analysis, video analysis. Three quick examples of image and video analysis, and let us debate that which ones of them makes business value, which ones of them are sustainable. So the first one, and these are real examples, guys. These are few real examples I have sold or architected or delivered in my lifetime. So the first one is pretty easy. I'll start with an easy one. So basically, you upload a photo for any of the applications, any of the account creations, and your photo is matched with other databases, maybe government databases, maybe other private databases. So let's say things like fraud databases, your photos is matched, your signatures are matched, and all those things. So very good use case for image analysis. So it cuts down the physical checking time. Also, it is not prone to human error and human beliefs. So wonderful use case, good business value, sustainable, because once you build this app once, it is going to do the validation and checking through the APIs without any other cost being put in from the long term. Now let's come to the second example, the two pretty ladies who are entering a shop, and this was more of a jewelry shop or a high-end fashion shop. So they have face recognition technologies from computer vision, wherein they could identify if you have visited that shop before. Who are you? What are your demographics? What did you buy or not buy the last time you came to the shop? Excellent idea. But let's think again, the three things: business value, experience, and sustainability. Let's think whether it actually brings in business value for everyone. Let's say the shop is a jewelry shop, or maybe a very high-end fashion shop like a Rolex or maybe a Prada. How many times in a year would the same person go back to a jewelry shop or a Prada? Maybe not many times. Maybe 80% of your customers in a jewelry shop or a Prada shop would be first-time customers. Maybe 75% of the customers in a Prada shop has entered the shop just to do window shopping, not buy anything else. Now, by recognizing the few customers who have come there earlier, and by getting the insight what they have bought last time and what they are going, probably predict what they are going to buy this time, is a good idea, but it is not sustainable, because to get two such sales, to get two such people, you are going to scan thousands of people and run the entire program on thousands of people who are visiting your shop, probably just for window shopping. So nice idea, creates business value in the short term, but is not sustainable. So these kind of use cases are the ones which probably comes up with a lot of enthusiasm, but doesn't see the day of light. So these three things are very important: business value, sustainability, and experience. So had it been not a jewelry or a Prada shop, had it been a bank, the entire use case changes. So by recognizing somebody who is entering a bank, if you know who is that customer even before asking him, and you notify the relationship manager that your customer is here, you can probably go and meet him or her in the lobby, and the person takes your docket or file in hand and comes meeting you. You need not stand in the queue in case you are a high net worth customer. Entirely changes your experience, and you are probably going to do more transaction with the bank and be with the bank for a longer time. Makes business value is sustainable. The third diagram herein is another interesting use case. So I remember in one of the Middle Eastern countries, in fact, for Hajj, one of my earlier companies did a project where we were using image and video analysis to do crowd management. So essentially, if there is a lot of people in certain queues at certain places, or certain points of interest in the Hajj trip, we were able to identify using computer vision, and we were able to simulate other alternate routes, or add buses, or do public or tell the public to take alternate routes to a point of interest, so that crowd is always under managed. Something business value, of course, great business value, quick win. The experience is very different. So rather than waiting in a queue, you get alternate suggestions that why don't you take that route, or go out to the circle and take that bus and hop out there. There is an alternate route to that point of interest, and things like that, and sustainable as well. So that's where Industry 4.0 is going digital. We talked a lot about all these things. I'm not going to go through the slides. These are some examples how the health industry, and the next slide is about banking. They are going digital. So
the screen is not shared. Sorry to interrupt. The screen is not shared again.
So how much did you get?
Till the last 3 or 4 topics you are discussing, the screen is not shared. I mean, for last 5 minutes probably.
Okay, but it shows shared on my side. Let me represent it.
But
okay, yeah, it is now shared. Yeah, fine. Yeah, okay.
So essentially, this is a hospital of tomorrow. It's a very, very, very wordy slide. So don't get into reading the slides. So let me tell you some few nice experiences that a hospital of tomorrow is using all these digital technologies for. So a patient comes in with an e-appointment, wherein his outpatient or his bed is automatically scheduled before even he comes in, so that he does not have to sit outside for 4 hours, 5 hours before he gets a bed. His health file has been digitized. So it might be digitized on spot as well. So basically we carry prescriptions to the hospitals, right? For last 10 years, we have stored all our prescriptions in a file. So we carry that file. The file will be read by a scanner, which will actually apply NFC and OCR on top of it, and your health file is going to be digitized in digital forms. Now, then there are digital nurses. What is a digital nurse? It is a station which reads your temperature and your vital vital stats before pushing to the doctor. So in a hospital of tomorrow, a physical nurse doesn't come in and take your temperature, your pulse, your vitals, etc. It's to be done by a digital nurse. So moving on to doctors. So you are there in the hospital, wonderful experience as a patient. How does digital change the gamut for the doctors? So nowadays, in a hospital of tomorrow, again, it's very, these are all these technologies are very nascent, and I have been fortunate to work with a couple of big hospitals in deploying these technologies, all of them. So how it changes for the doctors or surgeons? Earlier, doctors has to write your entire history on a paper, and doctors are mostly not very computer savvy. They hate typing your history on the computer. Similarly, for a surgeon used to write your entire surgery notes, how much anesthesia has been given, where he is making the incision, where he is doing the cut in your heart hole, and all those things. He had to write entirely, and as I said, doctors do not like typing. So now what we have done is that what the new technologies let you do is that digitize the entire prescription clinical notes. So the doctor will only keep on speaking. So I am doing the heart incision at 3.4 centimeter above the C4 of the spine, things like that. He will keep speaking, and the computer will keep taking note of his speeches. Not only that, it is backed by data. Remember the digital data hub, where we are marrying the IoT data, sensor data, etc. So there are sensors all over. The computer is also taking record from the heart rate sensors, from the pulse oximeters at every interval of time, and storing it in the same form. Plus, what the computer is doing is that it is backed by a medical dictionary. The medical terminologies the doctor is saying, it can identify that and probably tell the doctor based on earlier surgeries, or during a diagnosis, probably tell a doctor. So whenever a doctor says blood sugar, family history of blood sugar, hypertension, the soft robots will go back to the database, see thousands of such diagnoses which has been done earlier, and predict probably you need to give medication 1, 2, 3, 4, Senzipine or metformin, or for this kind of patients with this age also having a hypertension, metformin will not work. Please think whether you want to prescribe a Forxiga or something like that. So doctor need not write anything. The prescription will be ready. The proposed tests and the medicines will be on the screen of the doctor. Doctor just clicks. So accept, reject, prints it out. Your diagnosis is done. So essentially revolutionizing the doctors, patients, surgeons, even nurses and pharmacists experience. We nowadays no more do tablet cutting in Singapore. So there are robotic arms. So basically, person comes with a prescription to a pharmacy. It is scanned. All the medicines are read through NLP OCR, and the work of the pharmacist is to just go through the medicines and understand whether the medicines are all fine, etc. Because sometimes if there are certain medicines which are risky, the pharmacist will not want to give you in very high dose or high quantities. So he changes the quantities there, and immediately, automatically, control commands go to the robots, who will pick, pack medicines, get it into a folder, get it back to you through a automated guided automated cart or something. So entirely changing the experience, entirely changing the workflow per se. Similarly in banking, I will probably, we are probably nearing end of time. I will not go through that. But similarly in banking from anywhere, variable driven banking, voice driven banking. You can do peer-to-peer payments using social media as well. Remember the digital data hubs and the automation we talked about. So you can actually share 100 rupees with your friend with whom you are connected on Facebook, to pay for a coffee he paid for you the earlier evening. And the P2P is point-to-point payment will take care of the money coming out of your account and the money going to his account. Of course, there are multiple security features. It is covered with multiple security features. But in Facebook, in your iMessage, you can actually transfer money today. I'll not get into the details. It will probably go on for hours if I get into details of each of these digital use cases, but you can read it in your leisure. I'll share the slides for you. My final slide. What does it mean to you? What does it mean to my fellow engineers and the students? How the digital job market is going to see these disruptions? So essentially 4 roles I talk about. So of course, there are going to be data engineers, data scientists, and data architects who will take care of the back end and the intelligence part of the digital technologies. Then there would be a group of cloud engineer and architects who will take care of the automation, the templatization, serverless, cloud security, DevOps, CI/CD. So CI/CD means continuous innovation, continuous development. So basically the curve of innovation, keeping it ahead with the cloud infrastructure. So all these things has given rise to a section of job roles which we call cloud engineers and architects. So data engineers and architects, cloud engineer and architects. The third group will be the application engineer and architects who will work on the microservices, the APIs, developing the front ends, channels, robots, and all those things. And finally, all of them will be knit together by the domain technologists. Domain technologists will not only be engineers, probably they will also be engineers who have probably gone to a B school later or done a business management course and develop themselves into domain technologists. It's like a healthcare technologist, banking technologist, insurance technologist, who will know the regulations, patient safety, customer data safety, who will know how to embed the artificial intelligence into the devices that matter to that industry. So for example, for a port, automated crane or autonomous crane matters to pick up the containers without any people actually controlling them. But an automated crane doesn't matter to an insurance company, right? So for insurance company, you will have to embed the intelligence into devices that matter to that industry. So all these skills will be brought in by the domain technologies. So that is how essentially on a very high level, the job market is going to open with it. And you are, if you are able to cut yourself across 2 or more than 2 of these four pillars, you will be given a name called full stack. So full stack is they are most paid guys in the industry. So if you have experience in data architecture as well as cloud architecture as well as a little bit of application architecture, you will become a full stack architect. So I'm sure many of them will aim for it in the years and the decades to come. So my closing slide, what lies ahead? Digital twins is something which is being invested a lot nowadays in the market. Basically making a replica of yours as a human or as a machine or as a car. So making an exact digital replica of yours for simulation, for monitoring, for administration. This is going to revolutionize absolutely the Industry 4.0. Maybe we will have a new name for Industry 4.0. Things that are coming up are not yet fully defined. Things like nanotechnology, hyper-automation, industry style is still trying to define that. They are not yet really defined. So that's it. Remember, the Terminator has promised to come back, and probably going through all these things, we are actually building a Terminator. So it will be over to you guys, the students of today who are going to be the industry veterans of tomorrow. Please be sure not to build this Terminator and make it back to life. So that's my time, guys. Before I stop, I wanted to ask you a question. let's see if someone can can answer to it. So we talked about Amazon Alexa. Maybe I will think that many people have one of these voice-based assistants at your home. So can someone tell me what is the Indian voice of Alexa called? Alexa has a voice for most of the countries and the languages. So for India, there is two names given to two voices which are now available on Alexa. So can someone tell me what are those two names given to the Alexa voices in India? And I will clap for him or her. That's the prize, guys. And this question is only for the students. Wonderful, Amitabh Bachchan's voice. I like the identifier. Unfortunately, not. So there is yet to be a male voice for Alexa in India. So Alexa in India has. Let me give you the answer. Alexa in India has two voices. It's a fun fact for you to know. The voices are called Aditi and Ravina. And while Aditi can speak Hindi and English, Ravina speaks only English. So keep watching. I always wanted to be a part of a project where I can build more voices and skills for Alexa. I didn't get that job yet, but probably I will one day. So keep watching for this space. Over to you, Shorab and everyone. Thanks for being so patient throughout my time. And any questions I would love to take.
So, any questions? Any other questions?
Can you explain API? Okay, so let's say, Shubham, let's say you are building a program to do image recognition. Let's say you are collaborating with Dr. Reek and building a program to do real-time image feature extraction and image analysis. Wonderful, we have done that. How are you going to sell it? How are you going to sell it? Is things like, so let's say I am sitting somewhere in US. I am a buyer. I want to use image-based, real-time image-based analysis. So one way for you to sell it to me is come to my office, show me the demonstration, and install it on my software, and I will start using it. But one other way of selling it is the API. So what you do is that you create an API out of it. API is more like a web address. Just the difference is it does not give you a web page, but give you access to your program as a web address. So you just share that web address on a cloud, and you tell me whoever wants to use this API can call this web address, and I will be charging you 50 cents or $1 per call. That's an API. So you expose your program with security measures as an API, put it on cloud, and let any user in the world call your API for the image analysis use case that he might be having on his office. And you charge $1 per call. And the charging will be controlled by the cloud provider. He will ensure money comes out of my account and goes to your account. That's another API, by the way. So essentially, that is the API economy. You have built a program. You have exposed it with an API. I am a user. I don't even know you. I am subscribing to your API. I am using it, and you are getting money in return. That's it. On a very high level.
So, any other questions? Somaratno Devnath, another question is there.
Digital traffic will increase exponentially. How will this problem be addressed in future or near future? Shomoratno, nice question. As you have correctly observed that the traffic is going to increase. So what we have done is that we are already in the 5G era. It's not in future. People are putting in 5G, and your network speed and bandwidth is going to go up a lot. Plus, look at the cloud providers. Unlike earlier days, nobody is charging you for the entire dedicated bandwidth. Bandwidth is being charged to you on a pay-as-you-go basis. The amount of terabytes you consume for all your customers in a bank in a month, you will be only charged for that. And the cloud providers, and many of them are backed by telecom providers, the cloud providers and telecom providers have joined hands to bring in 5G and above on their infrastructure, on the network backbone, and making that network backbone consumable to the end customer with a very small price tag per unit. So that's where the increase in digital traffic is going to be not only controlled but also built and scaled, unitarily, if I will. I hope I answered your question.
Another question from Ruhul Amin, just previous. Is it safe any voice-based AI like Alexa or Google Assistant? Is they not hearing every time? Just
they are absolutely they are hearing you all the time. Don't be fooled. When your Siri is sleeping, when you don't say Siri, it is still hearing you. Every moment it is hearing you. So if you don't want them to intrude in your privacy, throw away iPhone and Google phones and Alexa and Siri, everything. They are hearing you every moment. Now, on the question whether they are safe from a transaction perspective, so whether they are safe from a hearing perspective, absolutely no. They hear everything. Whether they are safe from a transaction perspective, absolutely yes. Because when you are doing transactions through Alexa or Google Assistant, the transaction is no more in the device or no more in your home. It has actually reached back to the cloud, then onto the corporate network, wherein the transaction and your security, everything is managed by that cloud and the network. Yes, you will probably, if you ask Siri to do $100 transaction on your behalf, if you are giving a voice command, yes, you will have to attach Siri to your user ID password. So in theory, somebody can manipulate Siri to take your user ID password. But hey, that's the world, right? That's means 0.001% of cyber hacking will actually always happen. Means it will happen without Siri as well. If you are going to a bank, or if you're not going to a bank and using your internet channel to do a transaction, that is equally vulnerable to risk and threats like Siri. If you are going to stand in a queue and write a check to the teller, let me tell you that physical transaction is much more riskier than a digital transaction. Our benchmarks have shown that these physical banking frauds are at least 4x times the value of the cyber hacking and cyber attacks. Can we share our laptop for cloud service? Yes, actually you can. If you mean that if you would have a laptop on cloud, then of course you will not have a physical laptop. You still need a terminal. You will still need a terminal to access that, but you can have your entire laptop image on cloud, and every day morning you go to office, you can get that image and work on your laptop and shut down that image. This technology is called VDI. How GoDaddy works, please tell, sir. So I don't know what GoDaddy is. Probably is it the one which lets you build websites on top of it? I guess that is the one, if I vaguely remember. But essentially means that I will probably duck your question. I don't know how GoDaddy works, but how every service provider works is essentially at the back end there is an economic scale. Let it be websites, connectivity, cloud, infrastructure, server, whatever. And at the front end, there is conversion of that economies of scale into smaller parts, which is consumable by the user. That's how any service provider, cloud, website service provider, ISPs work. So I will duck your question on GoDaddy. It's not fair for me. I have never ever been engaged with GoDaddy to tell you how GoDaddy works, but I'll keep you to that. Anything else?
So any other questions? I think no.
I think we are out of time as well.
Okay. So,
It was a
so
very
I
nice
think
session.
there is no questions. So thank you very much, Mr. Banerjee, for your excellent, wonderful speech. Hope our participants have enjoyed a lot. We have also enjoyed a lot. Now I would like to request our HOD sir to say something. Dr. Dev, please.
Yes, sir.
Our token of appreciation, that certificate, if is so,
Yes.
to our speaker.
So thanks, Prosenjit. I like to thank our speaker, Mr. Prosenjit Banerjee, for enlightening us with his vast knowledge in this field. Once again, I like to thank Mr. Prosenjit Banerjee for taking out time from their busy schedule. Today's webinar is full of knowledge and interesting things. It gave deep insights into the topic and revealed more interesting facts. Both of our speakers in the morning session, Dr. Rick Das, and in this session, Prosenjit, gave us definitely the talk will definitely help us in our studies for the students and in the future also. So there is a token of appreciation for both the speakers.
Thank you, Dr. Shorav, and thank you, Dr. Shudip. I really enjoyed the sessions.
Welcome.
And thanks, Rick. Thanks, Rick. I forgot to thank you.
This is the EE appreciation. I will send you to by mail. And for the morning session,
so Shorav, one last point. As I said, I spell my name PRO.
Yeah. Sorry for that. Yeah. that is PRO. Okay, we have wrongly written that thing. Okay, so that you have to correct.
Okay,
yeah.
I'll send you slides. I'll send you the slides over mail. Over Gmail, I'll send you the slides. Thanks, everyone.
Okay. And for the morning session, this is the appreciation certificate of Dr. Rick Das. And we also want to thank our principal sir for giving the permission to organize this webinar. And we're also grateful to Dr. Gautam Das, Professor of ECE Department, for helping us and encouraging us to conduct this type of webinar. And we're also expressing our gratitude to all the participants attending their webinar and to make it successful. Please fill up the feedback form to get the e-certificate. Hope you will get e-certificate in coming 2 weeks. We also expect your kind cooperation from your end in the near future. Hope we'll arrange this type of webinars more. And thanks to all of you. Thanks, Prosenjit, and thanks, Rick, once again. It was a reunion of our 3 friends. Okay, so that's it. This is the end
that's
of
what
today.
made my Saturday evening great, guys. Thank you. Thanks. I appreciate everybody. Bye.
Okay. Thank you.
Okay, so we are coming at the end of this session, end of this webinar also. So on behalf of organizing committee, I would like to thank also IEEE Young Professionals who has technically collaborated with us, and we are really thankful to them. And we are really thankful to our HOD, the convener of this webinar. As you have all seen that both of the speakers are his classmates. So really we are thankful to our HOD. And lastly, we thank you all the participants. Okay, without you, this webinar will not be a successful one, because participants are the main. So in near future, if we probably we can arrange more webinars in near future. So we hope that all of you will join there also. And after the post that COVID time, if we organize this type of seminar workshop in our college also, so those who are not our that means those participants who are not part of CGEC, so please welcome you all to our Behar Government Engineering College if we arrange further so this type of seminar, workshop, or conference. This is a nice place, Cooch Behar. Okay, so this is in North Bengal of West Bengal. So those participants who are not part of CGEC, so please we welcome you all. Okay, if we organize this type of that is not online, in physical mode, if we organize some conference, seminar, or workshops, so please cooperate with us by participating. So that's the end. Okay, so Dr. De, please formally declare the end of this webinar.
So this is the end of the session. This is the end of the webinar, today's webinar. Thanks to all of you.
Oh, thank you.
Thank you.
So we are closing.